Well, good evening, everyone. My name is James Rosenstein. I'm part of the Tech Impact Forum, and we are delighted to welcome you to the Tech Impact Forum, which is an OLLI initiative in partnership with the Berkshire Innovation Center and One Berkshire. New technologies are having a major impact, as we know, on the nature of work, markets, education, training, economic development, and more. We are committed to advancing regional understanding of the nature and potential of current and emerging technologies and how best to take advantage of them while enhancing equity in the Berkshires. We're happy to provide more information. Today, we will be talking about the electrification of transportation, an urgent issue that has become of great importance. Given the major role of transportation worldwide in the increasing level of greenhouse gas emissions, it has become clear for years that electrification is the best way forward. At the same time, it must be understood that electrification is the biggest transition the automotive industry has ever had to face. Our moderator, I'm very happy to introduce you to Eric Planey, who is CEO of Solablock as of September 2021. Eric has over 25 years of experience in global banking and international economic development, with expertise in emerging clean technologies. His most recent position, prior to Solablock, was Director of Leveraged Finance at Sumitomo Mitsui Bank in New York City, where he covered private equity-backed relationships in the automotive, aerospace, and energy industries. Eric, it's a pleasure to hand over to you.
Well, thank you, James, and thank you everybody for attending this evening. I first, before I begin, want to give a personal thanks to everybody in what I like to call the Berkshire Innovation Community and Ecosystem, that is being the Berkshire Innovation Center, OLLI, Berkshire Community College, and everybody who participates in taking a wonderful area in Western Massachusetts and really growing it and developing it to meet the challenges of the next century. And this forum is proof positive of the great work that is being done already. And thank you very much for that introduction. A little bit of housekeeping, as Andy from BCC mentioned. If you do have any questions for our panelists, please use the chat function to write them down. We're going to let our panelists do their presentations first, and then we'll enter the Q&A. I'll be responsible for introducing those questions. I assume some questions may overlap in topic, so I'll do my best to consolidate it for scope and for the purpose of being efficient as possible in terms of time. As we begin, one thing that's very interesting, I have a podcast called Pirates of Clean Tech, and really a highlight of my podcast with my friend Lucas Finko last year was having one of the industry stalwarts in the automotive industry as a guest. That's a gentleman by the name of Dr. Andy Palmer. Andy was the former COO of Nissan and former CEO of Aston Martin, and now is currently the CEO of a British electric bus company. And one thing that really struck me in his presentation to us in our conversation is that the future of mobility is going to have multiple solutions. It's not just going to be battery, and it's just not going to be fuel cell. It's going to be a whole combination of things that are appropriate for the type of transportation involved. And obviously, over the last year, everybody seems to be talking about hydrogen as a mobility solution and also a solution for greater challenges within the global energy context. So it is really, truly an honor to have two gentlemen that have great expertise in understanding hydrogen as a propellant for mobility. First, I'm going to introduce both panelists, and then we'll begin with Stephan. But first, let me introduce Stephan Herbst, who is based in Belgium right now, so we truly have global representation for this panelist discussion. Stephan is the technical head of Powertrain Hydrogen and Fuel Cell Business Unit for Toyota Motor Europe's R&D and Fuel Cell Business Group. In part of that, he is involved directly in hydrogen strategy and is involved in new products and sustainable mobility solutions. He is actively involved in the in management of the Hydrogen Council and actively involved in Hydrogen Europe. On the other side, in California, we have Ash Carson, who is the senior manager for the Electrified Vehicle Technologies Office of Toyota for North America. actively working with corporate strategy and their planning group. And a lot of his responsibilities revolve around North American electrified mobility progression, fuel cell powertrain development, and hydrogen infrastructure enablement, which is something very important that we will talk about. Their full bios are available in the email that you saw or on the website for this presentation. So with that, I'd like to turn it over to Stephan in Belgium, who will begin his presentation. Thank you.
Okay, thank you very much, Eric, and good morning, good afternoon, good evening, wherever you are. As you can see, I'm in Belgium and outside is as dark as my background. Let me share my screen and I hope it will work. So now you should be able to see the presentation.
Looks good.
Okay, excellent. So let's go ahead. In the next 20, 30 minutes, I will explain you a bit what is hydrogen, how does it work, and what are the advantages, and actually why do we need battery electric and fuel cell vehicles to decarbonize transport. But let's start with what is hydrogen. Hydrogen is not new. As you can see already in 1874, Jules Verne had a vision that water will be the coal of the future. And for a very long time, even many European cities, the lighting system was powered by hydrogen. So hydrogen was already part of the society of our development for a very long time. Now hydrogen, what is it? As you can see in these chemical elements, H2, and H2 contains H2, so that means you can produce it from water, which is H2O, or from methane, which is CH4. You can see, so hydrogen is really plentiful available, and it's the most abundant element actually on Earth. That is why it makes is so attractive actually to utilize this as a future energy carrier. When we look into different ways how to produce hydrogen, and I will not go into all these pathways, but just to say you can utilize hydrogen by separating the oxygen from water, so H2O, you separate the oxygen by an electrolysis process, which requires electricity, and this electricity can come from renewables, from biomass, or of course also from fossil fuels. Then there is some biochemical conversion possibility based on algae, and the most common, I would say today, is the thermochemical conversion with SMR or other techniques by using fossil fuels, so producing a syngas, and out of the syngas hydrogen. So these are in essence the different pathways to produce hydrogen. And what is important to note that hydrogen is an energy carrier. It is not an energy by itself, it carries the energy, and it releases, and that is important for the use, it releases electricity and it releases power when it reacts again with oxygen. There are different colors of hydrogen. You might have heard gray, blue, green, red. Gray hydrogen is the hydrogen available today, a large majority. So this is hydrogen based on natural gas, on fossil fuels. Then we talk about blue hydrogen when we use fossil fuels, for example, natural gas, but we capture the CO2 out of this process in a carbon capture utilization or carbon capture storage process. And then last but not least, green hydrogen is when we really use biomass or green electricity to produce hydrogen with an electrolyzer. And red hydrogen I've mentioned actually is hydrogen that is coming from nuclear. In the Hydrogen Council, you can see we have made a forecast about the development. As I said, today, mostly gray hydrogen is available, but it's clear if we want to decarbonize, we need to move into a blue and a green hydrogen scenario. And this is what we came up. And actually, our analysis shows that you could do a completely 100% blue hydrogen future. There is sufficient storage capacity worldwide available. And you could also do a 100% green hydrogen economy because there is sufficient renewables, sun, space available. The decisive factor is the cost, and it is most cost effective to have a mixed case between blue and green to capture, to utilize actually the regional circumstances. If you're in Saudi Arabia, you have lots of sun, lots of space, then green or blue hydrogen might make sense. In other areas, it is more blue or it is more green. It really depends on the energy that you have available. What are the benefits of hydrogen? As I explained, it has the potential to be zero carbon footprint when it is produced from green or when it's utilized blue hydrogen. It can be stored, and hydrogen can be transported over long distances, for example, from the Middle East, from Norway, from Australia, from Chile. It has a high energy density, up to 100 times higher than lithium. It provides clean power and it provides clean heat. And last but not least, it is also a sector coupling effect. Let me move this. It serves as a feedstock in many industries, including carbon capture and utilization. Having said that, now let's move to the vehicle itself. What is a fuel cell vehicle? Fuel cell vehicle, in essence, is an electric car because it is powered by an electric engine. The difference to a battery electric vehicle is that the battery is not stored in the battery, but the hydrogen or the energy is stored in the energy carrier, which is hydrogen. So we store hydrogen at 700 bar. And you can see here the yellow tanks. The new Mirai has 5.6 kilograms of hydrogen, which gives it a driving range of more than 600 kilometers. When we look more at the difference or the similarity between a fuel cell stack and a lithium battery, and that is what you can see here. On the left side, you see a fuel cell stack. Actually, what does the fuel cell stack do? It uses the hydrogen. We utilize oxygen from outside, which is plentiful available. And hydrogen is reacting in the stack with oxygen. So there's a chemical process, which is releasing a lot of heat and a lot of electricity, which then we utilize actually to power the electric motor. Now on the right side, you can see a lithium battery. Actually, it looks similar and the physics are not so different, but the main difference is that the electricity is stored in the battery, not externally in tanks, but in the battery, and then we utilized in an electric motor. Now you can start to play around actually with these two elements. On the right side, you can see a fuel cell dominant system. We talk about fuel cell dominant system when the power for the electric motor comes mainly from the battery. So the Mirai has a 129 kilowatt fuel cell, which is providing the power directly via a converter to the electric motor. Then on the left side, we have variants, so-called range extender. This we utilize, for example, for buses. Here, the main power comes from the battery, and the fuel cell is constantly charging the battery. And between these two extremes, you can, as you understand, play around with the battery size and with the fuel cell size to come to different solutions. Now, let me turn back to hydrogen and the complementary role of both. So both have advantages and disadvantages. Very briefly, hydrogen, as you know, the disadvantage is it has a lower energy efficiency, and I will come to this point. It requires a dedicated infrastructure, distribution network. On the positive side, it has fast charging possibilities. So the Mirai, we refuel in 5 minutes. The target for buses, for trucks is 10 minutes. So very comparable with conventional options today. And hydrogen has a high energy per mass. This is why in all vehicles where we have limited space and where we are constrained in weight, we can store a higher amount of energy with hydrogen than in lithium batteries. So lithium, on the other side, has a higher energy efficiency in vehicles. The distribution infrastructure is easier to realize at the beginning. I say at the beginning because as soon as we go into volume and into wider fleet applications, we will see that there will be grid issues and grid upgrade required. The downside is there's slow charging, and the energy mass is also lower than in hydrogen, as I have mentioned. So it is not either or, it is both. That is the message, and we need to understand the customer requirements if a customer goes for hydrogen or for lithium batteries. So to summarize, and we just published in the Hydrogen Council a dedicated study on transport. And what you can see here, we need battery electric vehicle for a fast decarbonization, and battery electric vehicle will dominate in many user cases, especially from passenger cars, less towards heavy duty trucks. Fuel cell has a clear advantage when you have a constraint of renewable available, when there is a high power demand, so think of trucks, think of buses, or when there are long range and fast charging requirements. So think of taxi fleets or ride-hailing applications. Or as you can see on this picture, simply if there are space constraints and space limitations that does not allow overnight charging. So here fuel cell has a clear advantage. Looking at the global picture, we see an environmental revolution is going on, also with the results, the steps taken in Glasgow. But in total, we have now countries representing 75% of global GDP who have committed to zero emission or who have or will introduce carbon trading. So this is a massive trend. That is also obviously a question, how can we decarbonize transport? And transport sector today accounts for more than 20% of the final energy consumption. And even worse, we still depend more than 95% on fossil fuels. So it's a huge challenge to decarbonize this sector. Looking forward, also, we try to make a forecast what happens by 2030 and by 2050. And what you actually can see on this slide is there is power in black, mobility in blue, heating, new industries. So new industries is specifically the steel industry, who has increasing interest to utilize hydrogen. And existing industries is mainly the chemical industry, which is using hydrogen today to produce fertilizer or using in refineries. So looking forward, what becomes clear that hydrogen will play a major role in mobility. And our forecast clearly shows that the hydrogen uptake in mobility will be quite significant towards 2030, but even more and in 2050. If we look, have a closer look, what happens between now and 2030. So starting point is today we produce around 90 million tons per year of hydrogen. There will be an increase of the existing hydrogen usage. Think about refineries who need also more hydrogen in the future. Then steel industry, as I mentioned. Mobility is developing many projects, and then the heating and the power sector, leading to a consumption and production of 140 million tons by 2030. If we look what is required in terms of global investment in order to make this happen. And here again, you see the different sectors and the investment needed for the production, for the distribution, and also for the demand side. What is clear for transport, we almost need an equal investment in the production, but as transport is very decentralized, obviously also in the distribution and in the setup of a hydrogen network. And then also we need the investments for the vehicles. We have now the Mirai on the truck. Ash will show you the truck in the US. We have buses, we have vans. So we are working on trains with partners, on ferry, on stationary applications. So the number of applications in the transport sector will increase, and hence the investment that you can see will also be significant between now and 2030. But what we also analyzed is how much of this investment is already committed today. And as you can see, committed or announced are around $160 billion US, but we still have a significant gap to close to reach the investment needed, which is around $700 billion by 2030 for production, distribution, and actually the end-use applications. So discussions going on. Also, European and US have now put big incentive plans for hydrogen on the table to promote this, to stimulate also financial mechanisms, and the financial industry is playing a key role in this regard to unlock actually this investment and to make this happen in order to realize the full potential of hydrogen. We also count the number of projects, and actually we see since January this year an increase of 50 to 100% in terms of large-scale projects. What you can see on this graph is the projects. Many projects are happening in the US, but also South America, especially in Chile, in Asia, in Japan, in Australia, in China. But also Europe is at the moment leading with around 221 large-scale industrial projects that are currently, no, 261, sorry, projects that are currently going on in Europe as part, for example, of the so-called IPCEI projects, so projects of common European interest. So it is the clear and target of the European Commission and many member states to make hydrogen a fundamental part of the new economy, and that we will see to decarbonize and reach the Paris Agreement. Now let me turn towards transport and why we think battery electric and fuel cell have a complementary role to play. We have developed in the Hydrogen Council 12 facts around this complementary role. And this is summarized in 3 areas. We believe in this complementary world, we can decarbonize greener, we can be faster, and we can be cheaper. The key arguments on greener is the system efficiency is comparable, life cycle emissions are comparable, there's an additional storage and import possibility to utilize more renewable electricity, and we can actually ease the resource demand for certain materials like cobalt and nickel or lithium that is required for battery faster. We are independent from the electricity mix. We can provide additional capacity for this decarbonization transition, and actually we can utilize a greater momentum by focusing on both technologies, because we can offer more convenience and more flexibility to customers, and we can, number 9, better respond to situational and regional situations. And cheaper, finally, also because hydrogen is the cheapest option in many situations, and to infrastructure actually can be cheaper as one. So let me not touch on all, but just on some of the selected items. The first is on the efficiency. Let me explain this chart. What you can see on the left side is we assumed the output of 1 kilowatt solar panel here in Germany or in Northern Europe, which has a load factor of 11%. So the starting point is 950 kilowatt. This electricity we utilize in a battery electric vehicle. So we have losses because of the transmission, and we have around 18% tank to wheel losses in a battery electric vehicle. So which gives you 680 kilowatt, which means the car can drive a battery electric vehicle 6,100 kilometers. The next case is we take the same 1 kilowatt solar panel, but this time in the Middle East. So there's more sun. The load factor is accordingly higher, 25%, and our starting point is higher, so 2,200 kilowatt. Now we cannot use the electricity produced in the Middle East in Europe, but we can produce hydrogen, we can liquefy it, ship it to Europe, utilize it here directly in fuel cell vehicles, and you see the higher tank to wheel losses, which we assume here 50% for fuel cell vehicles. And despite this, we have almost the same driving range as for battery electric vehicles using solar energy from Germany. And the last case actually is again 1 kilowatt solar panel in Germany. But today we cannot take up renewable electricity quite often because there is no demand when it's being produced. So there is a loss of around 1 billion already today. If we just capture 2% of this curtailed electricity, we can actually produce another 70 kilowatt, or at the end we have 70 kilowatt hours available for fuel cell vehicles. That means in addition to the 6,100 kilometers for a battery electric, we can generate another 600 kilometers for a fuel cell electric vehicle. So again, in this combined world, we can be more efficient and we can decarbonize faster. So the argument that a battery electric vehicle is more efficient than fuel cell is correct, but it is not correct, or it gives a different impression if we really look at a systemic level and how we can optimize the energy and the available of renewable energy globally. Then this slide is just reiterating what I said about the peaks. When we have imbalances in the electric system, we have green hydrogen available, there's an oversupply. And as I mentioned, this accumulates at the moment to around 1 billion alone for Germany. And we have situations where we need more electricity, but there is not sufficient green electricity available, for example, during the night. So hydrogen can obviously help to balance this. We can utilize the surplus, produce hydrogen, and utilize it when energy is required, when there is an undersupply. Also, the complementary role is, and here you can see the different actual decarbonization status of the electricity grid. So Sweden, very green, using a lot of renewables, and Poland using a lot of coal. The key point is here, when you connect your battery electric vehicle to the grid, you always get the mix, the energy mix of the respective country. It is only then zero emission if you directly can link your car to a solar panel. If you produce electricity by yourself and you use it directly, otherwise, obviously you get this energy mix. While for fuel cell, if hydrogen is produced from renewables in a green way, then you have immediately zero emission vehicles by using this green hydrogen. Convenience and flexibility is also key. This is a survey done in North America, in Germany, and in China. And what is key for customers is access to fueling and charging stations. The number one criteria, driving range is important, and then also the lifetime and durability of vehicles. Also here, as we saw before, hydrogen and lithium batteries are actually complementary, and we try to capture this on this slide. What you can see horizontally actually are different customer groups, starting from the left, middle-aged, living in suburbs, and then parents in a city home, until the right side where you have commercial applications for taxis, light commercial vehicles, but also bus operations and truck operations. And each segment has different purchasing criteria that you can see vertically, be it cost, be it range, charging access, infrastructure requirements, or durability. Now, having said that, there are very clear cases for hydrogen. This is more towards the commercial side for buses, for taxis, as I mentioned before. And there are more clear cases for pure battery electric vehicles. Take a middle-aged living in suburbs in a house having access to overnight charging. So for this person, a battery electric vehicle is absolutely sufficient. But we have also many cases in between where it very much depends. So for example, take the family going on holiday. If the vehicle is just used for shopping trips, for shorter trips, a battery electric vehicle might be suitable. But if the same car is used, for example, also for longer business trips in the same family, then a hydrogen vehicle might be a better option. So it really depends for many segments on the individual situation of the customer. But the key message that we want to give with this chart is that by having both technologies, offering both technologies, we can reach more customers and we can decarbonize much faster because the uptake of zero emission vehicles will be higher because we can better respond actually to customer requirements. Now let's quickly jump to total cost of ownership. We also in a separate study published last year looked into as of when can fuel cell vehicle reach break even with battery electric vehicles and in some cases even with conventional options. What we can clearly see in Europe, for example, in the E segment, in the taxi market, we see a clear a TCO break even around 2028. In the US, if you think about SUVs, we see this around 2030. And then in Japan, looking also into smaller segment, into C and D segment cars, the break even will be around 2036. That also has to do because the cost of infrastructure in Japan is significantly higher due to the legislative environment in Japan compared to US or Europe, why the break even is a little bit later. I mentioned that two infrastructures are cheaper than one, which sounds a bit strange. But what we calculated here is in a world of the Paris Agreement, when we fully decarbonize, we have calculated that for 1,000 passenger cars, if you have 100% BEV scenarios, the investment that you need for the grid and for the electric charging infrastructure is around 5.8 million. Now, if we reduce this 100% scenario to 90% scenario, we can reduce this cost already by 1.4 million. Then for 100 cars, actually by 2030, 2050, we assume the cost of a hydrogen station is around $300,000 in total. So we replace this 100% scenario with a 90% BEV and a 10% fuel cell scenario, and our total cost is 1 million lower per 1,000 passenger cars than in a pure battery electric scenario. Again, here the message is, and this 90-10 is just an assumption to visualize the effects. In a combined scenario, we can realize the investment in infrastructure cheaper than if we focus on a singular technology. That is also true if we look at highway charging requirements. As you can see on this slide, actually, during holidays and weekends, actually, the energy demand for passenger vehicles can go up to 4 megawatt. And then if you think about trucks coming, that is adding up to another 50 megawatts. So in total, this is a demand of a town with around 25,000 inhabitants. So this puts enormous pressure on the grid if this is fully electrified. While, as you can see on actually on this graph here, on the little image, you can serve the same amount of cars with one hydrogen station and 4 nozzles. So in terms of space impact and in terms of the electricity and the energy that we can carry to these highway stations, hydrogen can be complementary and take off the pressure on the grid and the pressure to deliver this amount of pure electricity to the highway stations. Last but not least, on materials, while we are working in the Hydrogen Council on a deep dive on materials, actually I used here a recent study from the International Energy Agency in the World Energy Outlook, where they looked into what is in a Paris environment, the future demand in copper, nickel, lithium, cobalt, and rare earth metals for batteries, but also for the electricity network and also for low emission power generation. And as you can see, the impact on the materials is enormous. Now, is this a problem? It can be a problem according to the IEA, because they say many of these materials are only available in certain countries. That means, and the IEA is arguing, the OPEC is nothing compared to such a cartel, actually, where we will more dependent on certain countries. Plus, if we take the ESG implications that we will see by sourcing so massively this material, this will have quite an impact. While for hydrogen technology, as you can see down here, there's much less an impact. And what we mainly need is platinum. And we are working towards having the same amount of platinum in the stack as we have in the catalysts today, which is around 7 to 10 grams. So that means every combustion engine that we take off the road, we can recycle the platinum and utilize this platinum for fuel cell production. Therefore, we have much less pressure on other materials, other metals with hydrogen. So important factor as well to keep in mind. Last but not least, in order to fully unlock the hydrogen demand, we need to stimulate the demand, the vehicles, ensure the stations and the low cost of hydrogen at the same time. And in order to do this, I just want to give you 4 examples from Europe, how we are doing this. Actually, we partner, for example, with infrastructure companies, with Air Liquide in France, to create a type, which is a ride-hailing scheme, now targeting to have 600 Mirais in ride-hailing in Paris. We just started a similar project in Denmark with more than 100 Mirai. We have a partnership with Uber in Germany, and we have introduced Toyota Caetano fuel cell bus in Europe. So we already sold more than 50 of this bus. All these examples will help to align actually the infrastructure and the demand in order to achieve our goals in building up hydrogen ecosystems and increasing the uptake of hydrogen. So I stop here. Thank you very much. And I hand over to Ash.
Stephan, thank you very much. I thought that presentation was really good about giving us proper context about hydrogen relative to other types of battery technology, and also in the context of developing a clean energy infrastructure, what it will really take. So we appreciate that. To all our participants, thank you. We've got over 10 questions so far, all of them very good. We're going to hold off in asking those questions until Ash is done presenting, just because some of the questions I believe Ash will answer in his presentation. And again, we'll give a chance for both panelists to answer at the end. With that, I want to turn over to Ash. I apologize to Ash. I introduced him as Ash Carson. I think his location in California must have had me thinking about Johnny Carson. And so it's Ash Corson, of course. And so Ash, I ask you to take it over from here, and we'll go into your presentation.
Thank you so much, Eric. No worries at all. Happy to do that. Let's see if I can share. go. Apologies if you have some background noise for me. Some of that infrastructure investment that Stephan so eloquently mentioned is taking place at our facility here. So we're adding a lot of hydrogen and battery electric solutions and the key infrastructure. So can everyone see that?
Looks good, yep.
Okay, great. So following Stephan's great comments, I'm going to give a bit of a picture of the North American and US landscape, and also use this heavy duty truck example. I think is a great example of electrification at scale and some of the challenges and pros and cons involved in terms of the technologies. And one of the reasons hydrogen fuel cell electric is a really compelling, scalable zero emission solution. I think Stephan did a great job of outlining the various sectors in the macro level. And I think passenger vehicles is one space, and personal mobility that we can all relate to, whether we're commuting, maybe not so much now in COVID times in our vehicles, but this really is a holistic conversation. And I'm going to touch on that in terms of not just the mobility side, but I think Eric mentioned as well, the power generation side. Really, it's how does society convert from really internal combustion engine and diesel specific power generation to cleaner, reduced carbon, zero emission solutions. And when you start talking about 1,000 trucks that are about 40 to 50 times that of a passenger vehicle in terms of the consumption of energy, and emit maybe 300 times the carbon and particulate matter that a vehicle does. So we're talking exponential order of magnitude, greater challenge, 80,000 pound type vehicle versus 3,000 pound or 4,000 pound vehicle. So it's a huge scale up. And that's one of the reasons I'm going to use the heavy truck example to be illustrative of those other areas that Stephan also mentioned, whether it's the ships and the trains and the large data center backup power, for example. The bigger the scale, the bigger the challenge for electrification in terms of pure battery, and often the greater the fit and scalability advantages for fuel cell electric. So again, as Toyota, we're impartial. We're presenting a portfolio approach, really recognizing that there are so many different customer needs, whether you're a suburban commuter, a taxi driver, a commercial truck driver, a fleet owner, a port operator, or a city governor, or a world leader, et cetera. Each state, country, and region has specific situational context, including the energy footprint and the mobility needs. So that being said, long story short, you really need to have a portfolio of solutions. We need to pull every lever we can to help reduce carbon in the fastest manner possible. So with that, let me get into the presentation proper. So this is really a heavy duty need. Again, as you go left to right across the screen, in red, you see the need is severe. And the heavy duty truck example, you see that pie chart, a little small, but that's representative of the Port of Los Angeles, which is America's biggest port. Some people may know that 40% of all US imports come through the Port of Los Angeles and on towards the rest of the country. And of that Port of Los Angeles footprint, in terms of emissions, you see that red part of the circle, that's heavy duty truck. And right behind that, the next biggest at 30% are the marine vessels, the big ships that are only getting bigger. And a lot of the times they're disadvantaged communities located right next to these high freight corridors. And so you see the heat map is the air quality index. And Los Angeles has some of the worst air quality in the world because of that port. And it's very concentrated, continuous, 24/7 type trucks and trains and ships operating, giving us all the goods that we need, right? It's a huge economic engine for the United States. And this is something that's also true in Port of Boston, for example, or Port of Houston, Seattle, Tacoma, et cetera. Not just all over the US, but all over the world. Port of Rotterdam, Port of Nagoya in Japan, all the big China ports, for example. So this is a universal situation, this need for cleaner freight and commercial and trucks. And it's a huge environmental justice challenge too. And that's one of the reasons, the middle of the page there, you see the real big push by the government. I saw a lot of great questions coming into the chat on what is the infrastructure bill? What does this mean for hydrogen electrification? And what does some of the mandates at the state level, California, but also the rest of the country. What does that all mean for electrification hydrogen? Long story short, it means a huge acceleration. That's one of the reasons we're so involved in this, and we have construction going on right now. California, as an example, is mandating by 2023, that's about a year and a couple months away, that a certain percentage of heavy duty trucks have to be zero emissions. And 13 more states across the US are following California's lead there. And the Biden administration, the Build Back Better, the Infrastructure Fund is also doing this. The ports are doing this even more aggressively too, because they're again at the crux. It's the perfect storm at the big ports where they have the need to expand to keep up with the growing e-commerce, but also the environmental justice aspects and the community health aspects. So that all feeds to the right of the page, the green box there, that zero emissions vehicles, ZEV for short, it's coming, and it's coming big, and it's accelerating in speed. The ports are saying no new diesel trucks by 2023, again, very soon. And California wants, as an example, 27,000 zero emissions heavy duty trucks over the next decade or so. What is the government and what are the states doing? Example is the Department of Energy, Secretary Granholm looked at one of the trucks you saw on my opening slide. We took them to DC, was very impressed, and lo and behold, we have $127 million devoted to super truck, including hydrogen as a focus. Because of that, seeing is believing. We have trucks with thousands of real world miles now in service, making a huge impact on emissions and carbon reduction. So that's happening. Also, there will be probably about $1 billion, I believe, going to hydrogen infrastructure, which is a real key, as you'll see in my talk. So lots of things happening. This just visually, a lot going on the slide, obviously, but visually helps portray a lot of what Stephan mentioned in terms of our portfolio approach and belief. Again, as I mentioned, one size does not fit all in terms of electrification, because each customer or ecosystem has a different situational context of needs and energies available and operating cycles. So really everything is needed. We need battery electric vehicles that are good for shorter range, fixed route, lighter cargo. In the middle, we need hybrid electrics, which is a great kind of a mid-range solution, which isn't infrastructure dependent, right? We have existing gas grids and electrical grids. We need to leverage those in this energy transition. It's not simply flicking a light switch and can convert everything over to electric. That would cripple the electrical grids, and everyone has existing assets that they're invested in, whether you're again, a truck operator or a port operator. The bigger blue space you see, again, the bigger the need for electrification, the better the scale fit for hydrogen fuel cell electric. And that's one of the reasons across trucks and buses and ships and power generation, we're heavily advancing fuel cell electric. Hybrid, I think everyone's quite familiar with this. Again, I think a key point, that second bullet up at the top, it's infrastructure independent, and it gives the customer flexibility. So you're a customer who lives in an apartment building without direct, garage charging for battery electric. That's not going to be easy for you. Or you're in Wyoming, for example, where there's not a lot of fast chargers or any chargers, and it's quite cold, which can reduce battery efficiencies by 30% or more. So really cut into your range. And fast charging alone really tends to reduce the performance of battery over time. So hybrid electric is still a great option to reduce carbon at a big scale. And so we'll continue to leverage that. Battery electric does have a great place for that kind of urban mobility, shorter range, again, lighter duty cycle, personal mobility. And so we're pursuing that in alignment, which I think is important with the regional infrastructure. And now that the renewable pathways are more clear and available, the time is right for that as well. So we're doing that in partnership with many other stakeholders. This again, fuel cell electric space, a lot going on here, but as you look left to right, you see kind of the progression from passenger vehicles, our very first generation Mirai there up at the top left, and the second generation beautiful new Mirai that we introduced, and then towards the heavier duty aspect, right? Again, the trucks, buses, and planes, trains, and ships. The bigger the scale, again, the better the fit. And there's that bottom right pictogram just represents port handling equipment, trains, ships, airs, right? There's global investment and R&D ongoing everywhere, part of that big bucket that Stephan mentioned, and the Hydrogen Council that he's a member of, really coordinating all of this. And then you see the energy majors are also wrestling with their transitions, and they're a key piece to all of this. There's the mobility side, and then there's also the energizing side. So an example being Toyota and Chevron announced a strategic partnership, an alliance on hydrogen. That's just one of many examples where the energy majors are plotting their own path, and we're coordinating that and helping guide that in their transitions from, say, natural gas to hydrogen in this case. And it's really a modular, scalable electrification. I won't touch too much on this because I think Stephan covered it well, but the complementary role of battery electric and fuel cell electric, where one is strong, the other may be challenged, and vice versa. So it's good to have both in the arsenal. And Stephan mentioned, I think, maybe 600-kilometer range, which is about 400 miles for our US lens. And recently, just out of my office here, we had a hypermiler come in and see what they could do with one of our new Mirais. And the EPA label is 402 miles per gallon equivalent, and we set a Guinness Book of World Record for 845 miles on one single tank. So that was pretty cool. It just illustrates the high range potential of the technology. Using, again, the heavy-duty truck lens for the reasons I described as a comparison against some of the pros and cons of battery electric on the left and fuel cell electric on the right, both electric solutions. As Stephan mentioned, fuel cell electric simply uses electrochemical reaction to make its electricity on board via feedstock of hydrogen and oxygen coming into the vehicle. So the hydrogen is stored on the vehicle in those high pressure tanks you saw, and the oxygen just flows through and is used a compressor to kind of accelerate the speed of it. So it just comes in from the air, and the only emissions is water, and you get a lot of benefits, as you can see from the bullet list there. In this heavy duty truck space, it's really a much closer capability-wise diesel equivalent, which is the benchmark for today's diesel trucks. And then one of the big challenges is all those diesel trucks, the emissions, as I mentioned, is brutal. It's a real issue. I think we've all been there when following a truck and seeing the soot come out of it, the particulate matter. It's not just an emissions issue too, though. There's so many benefits to going electric and fuel cell electric in this case. There's performance advantages. There's much greater torque, which makes it much safer for the drivers to merge onto freeways. It's much quieter, right? There's less noise pollution, so trucks can operate more 24/7 without disturbing the community. The drivers themselves, not only the emissions health impact for them, but also the lack of noise, vibration, and harshness. They don't get home at the end of the day exhausted from the continuous shaking of the diesel engine. And that's real. We've had, part of our team were UPS drivers, for example, in their previous lives, and they remarked they don't smell like diesel and they're not exhausted when they get home to play with their kids. So this is real benefits outside just the emissions story. Battery electric is a really good fit in many ways for kind of local, more lighter duty, single shift type operations, and about 200-mile or less cargoes where maybe your cargo isn't too heavy and you fill up your volume rather than wait out. So also the trick with passenger vehicles, it's easier to have public access charging stations, but for the trucks, it's a much more challenging thing. Again, use UPS as an example. Their time is so valuable, getting packages to all of us, and their driver's time so valuable that they can't afford to run the risk of pulling up to a public heavy-duty truck charging station if one were to exist, and this is the reason they don't, and wait for the truck ahead of them, say, for example, to finish charging. That's just not going to cut it. So they really need their own depot type setups, which comes with its own challenge. But fuel cell electric trucks, on the other hand, can utilize. There's 3 Shell stations, for example, in the Los Angeles area that are dedicated to these zero emissions Class 8 trucks that we're running with the likes of UPS. And so they are able to fill in minutes rather than charging for multiple hours. So long story short, there's a lot of advantages operationally in terms of cost and time and throughput that the fuel cell electric has. I think Stephan touched well on the bottom left. You see the bar chart there, and that's kind of the sun to well to wheel kind of conversation. in terms of the sourcing of precious metals and materials. The chart you see is the lithium battery example. And I think Stephan made a great point that vehicles already have platinum in there, which is the biggest kind of precious metal ingredient for fuel cell electric, for the cells themselves. That's already used in the catalytic converters. So the ratio of conversion to using the platinum, the equivalent platinum, just into a zero emissions vehicle is a great path. Whereas a lot of the copper and the nickel and the other things and lithium itself that are being sourced for pure batteries is a tough thing, because again, a lot of the areas are in conflict zones. The fundamentals, I think I've touched on this. The left, as you see, again, how a fuel cell vehicle works. I think it's interesting. You see some of the building blocks. You see the yellow tanks again. One of the reasons Toyota has, we've been the leader in this space, I would say, for almost 3 decades now. And one of the reasons for that is because it's really a zero emissions version of the hybrid. Everyone knows the Prius, and there are millions of hybrid vehicles that we sold in the US and around the world. And the fuel cell electric is you take out the internal combustion engine, you replace it with a fuel cell stack, and you take out the gasoline tank and replace it with hydrogen tank. There's a few more nuances in terms of the power electronics, but at its core, fuel cell electric is really a zero emissions version of the hybrid. So that's one of the reasons we were able to advance it and have so much confidence in its durability and favorable cost path. The key, as you probably well know, and I can't underscore more, is really the infrastructure. So that's the vehicle side technology works great, whether it's a passenger car or a big truck or a ship. The unlocking pacing item is definitely the infrastructure. The good news, as Stephan mentioned, is that the throughput for a single hydrogen station is much greater and requires much smaller footprint than the equivalent charging bays that you would need to have the same amount of vehicles or power generation through its gates, so to speak. What you see here is a California map. There's already 50 stations. When we launched our first fuel cell electric vehicle, the first Mirai, first generation, there were only 2 stations existing retail-wise, and now there's 50. So progress, not nearly as fast as we'd like, but good progress. Los Angeles to San Francisco coverage. More importantly, there's 120 now, or 120 more stations, excuse me, that have already been approved and funded that are coming in the next 3 years. And most exciting, in my opinion, is really this heavy-duty truck lever that I've talked about and that we're pursuing. That crucially gives the economies of scale to the Chevrons and the Shells and other energy providers of the world, not just because of the amount of consumption of energy, again, 40 to 50 times that of a passenger vehicle, but again, as I mentioned, the continuous nature and concentrated nature of that consumption. So the energy providers can plan their CapEx infrastructure scale investments around those heavy duty truck routes. And really what it boils down to is concentrated port ecosystems, those universal ecosystems that I mentioned at the outset, whether it's a seaport, an airport like Logan or something like that, or LAX here, or a land port, the huge distribution hubs, the Amazons, the UPSs, the FedExes, the Walmarts. They're giant warehouse distribution centers, or essentially land ports with serving thousands of trucks. So you really only need to locate a few big, high-scale, heavy-duty hydrogen stations, like we're showing here in Los Angeles, in those areas, and then you can kind of support the entire ecosystem. I won't touch on this much, but just to show the scalability, again, we took 2 essentially of our passenger vehicle Mirai systems and scaled them up to a Class 8 truck and buses and other vehicles like that. So modularity is great, and the plug and play aspect is really great. You don't have to reinvent the wheel, the entire truck in this case. You plug and play the powertrain into the vehicle. Our truck progression here in the US, I think back in 2017, we introduced Alpha, which had about 200-mile range, and we're talking about 80,000-pound combined weight, right? So this is a truck at full load, 200 miles. And then Beta we introduced in 18, which much faster development time, much lighter weight, 300-mile range, 100-mile range bump up, same wheelbase, but we had the sleeper cab, etc. So you can see the pace, the rapid pace of the improvement. And the Ocean program, we're running with the state of California and Shell and Kenworth. and others. UPS, like I mentioned, our own Toyota Logistics Services. So we've got 10 trucks now with thousands and thousands of in-service green zero emission miles, which is great progress. So these trucks here, you see some pictures of them. They're ready for prime time. They're doing hard work. I like the top middle picture there, which is a great well-to-wheel story emerging, right? We have a zero emissions truck delivering zero emissions vehicles to the end customers. And the stations are a huge part of that. We're already, we've tested these trucks at altitude. We're already into our second generation truck development and announcing the partnerships, as I mentioned, on the infrastructure side, which are the key enablers. The modularity is, again, think of them in short as Legos in many ways, that you can stack and daisy chain them together. The Mirai uses one stack. The Class 8 big semi trucks use two stacks, and then you can imagine for ships or data centers that you just have more stacks together. So it's a very promising technology for that scalability, not just on the infrastructure side in terms of throughput, but also the technology itself. And this slide really gives you a picture of what we're doing as Toyota to show the way. That middle is really, infrastructure is an expensive investment. So as we all collectively, whether we're an institution or a private citizen or a government, how do we electrify? What makes the most sense to transition to zero carbon neutrality based on our energy profile, our needs and our situational context? Again, how do we electrify? You really need a future-proof kind of one-stop, versatile green infrastructure. And this tri-generation plan is an example of us as Toyota introducing this into our Port of Los Angeles facility. It will be Toyota's North America's first 100% renewably powered facility. It uses a giant stationary fuel cell and biogas to produce renewable hydrogen for fuel cell electrics, cars and trucks, renewable electricity for battery electrics, and heat and for the facility. And then that renewable electricity can also be used to power not only the facility, but also export back to the grid. So it's a grid strengthener. Grids are vulnerable, particularly at scale. A lot of investment needs to happen. And hydrogen can not only be used as energy storage for the renewable cyclicality that Stephan outlined, but also to directly transfer clean energy to the grid, so strengthening the grid. Just quick examples of the fast rate of this heavy duty truck space. Again, an example of accelerating the station count. Those 50 stations I mentioned before, those are all light duty stations. So now there's already 5 dedicated heavy duty stations in California, and that's quickly going to grow in the next couple of years, more than double. Again, as I mentioned, it's the energy providers seeing this segment, these heavy duty trucks and beyond, as the key scale economy motivator. What does that mean for the rest of the country? Well, you see the green states or other ZEV states, including your neck of the woods, which is great. And then the ones outlined in red are also the ones I mentioned where it's not just light duty passenger vehicles that they're going to mandate to be zero emissions, but now the heavy duty truck space as well. And in blue, you see some of our Toyota side footprints reacting to this and helping lead the way, including we publicly announced in the middle of the country at our biggest plant worldwide, all of Toyota, is our Kentucky plant. And that's where we're producing these Class 8 fuel cell electric power generation modules. So that gives you an indication of the importance and the activity in the space. Last couple slides. This is also indicative of the general US kind of hydrogen progression picture. I think Stephan had a great map of the globe and of all of the bubbles taking place and growing. Same is true for sure in North America. So this is part of that, the Build Back Better, the Biden administration, the federal administration, and then the various states. There's a lot going on and it's starting to be linked together. I didn't mention the hydrogen shot. I think just this last slide. This is again Secretary Granholm in front of one of our trucks. The hydrogen shot is really important because that's Secretary Granholm and the DOE's commitment to helping fund $1 per kilogram green hydrogen production within the decade, so by 2030. And that's huge. Again, the momentum is, the tipping point has been reached. Again, part of the reason is this heavy duty truck lever. But paths like that for the hydrogen shot, I think it was quite notable that the very first energy shot was a hydrogen shot. that speaks volumes. Last slide, three slides, excuse me, quickly. Wheel chart on the left, another great DOE chart, which really shows the versatility of Swiss Army knife-like versatility of hydrogen. I won't delve into that. I think Stephan covered that well, but we really need, again, to leverage the electrical grid and strengthen the electrical grid, increase the resilience there, and leverage the gas grid, the carbon capture pathways to blue hydrogen, and then also leverage green hydrogen. And the great news on the right is that the US is really well situated, whether it's the favorable solar and wind conditions or the natural gas, highly developed natural gas industry and the carbon capture pathways. And then the electrolyzers at scale, another reason the trucks are important. They finally give the cost economies, the scale needed for large scale electrolyzer production. There's a little visual representation of the global picture too, just to complement Stephan. So lots of activity. The key big takeaways again are the tipping point, the global momentum has really been reached. The easy example is always China. They reach the scale challenges quicker than anybody arguably now, right? So they're trying to electrify and they've pivoted hard to have a good balance of both battery electric, but also fuel cell electric increasingly, because they recognize that hydrogen is really needed to tackle these harder to abate, bigger kind of concentrated port areas. And as a result, lots of stations are popping up along with the mobility needs. This just sums up kind of, again, why multiple paths are needed, that portfolio approach. You need synergy between these various technologies. So synergy between hybrid electric, battery electric, fuel cell electric. On the left, you have that diversity of customer needs, the e-transitional needs that we've talked about. We also have the flexible future-proofed e-infrastructure as kind of a core of that, and the communication and integration and linkage between the infrastructure, V2X as we call it, vehicle to everything, and the vehicles themselves. And then what that means for the goal pathways, the carbon neutrality all on the right, that you have these various technologies and they're all needed and provide different strengths. Hybrid electric really gives you that independent, flexible transitional scale. Battery electric gives you more human scale, and then clean, capable commercial scale for fuel cell electric. And really empowerment. I think we look beyond mobility and start thinking about empowerment, whether that's clean power, actually giving communities, you know, the tools they need to make this transition. So thanks so much. I will turn it back over to Eric.
Wow, thank you, Ash. That was a phenomenal presentation. Again, I think I'm probably reflecting the attitude of a lot of the listeners, which is really just overwhelming support for all the information that was taken in. There was a lot to take in. So Ash, while we give you a second to catch your breath after our presentation, we have over 30 questions is my last count. So I don't know if we can get to all of them, but some of them have some overriding themes. Before we get to specific questions for our two panelists, there were a couple questions regarding in the United States, Stephan, the current infrastructure bill that was just recently signed into law, I think yesterday, by President Biden. There's a question about how much of it is being spent on hydrogen. And maybe Ash, you can confirm this, but I saw a number while you guys were speaking, 9.5 billion is dedicated to hydrogen in the United States right now. 8 billion is allocated towards kind of creating a national hub, if you will, for hydrogen infrastructure development. And then 1.5 billion is dedicated in this infrastructure bill to some green hydrogen pilot projects in the United States. So Ash, I don't know if you've seen anything different, but that was the one number that came across in my very quick research while you were speaking.
Yeah, that's well said, Eric, and well encapsulated. The only thing I'd add is I think there's the potential for even more. Part of the infrastructure bill gives awards to, as you may know, to regions. So the Massachusetts region, for example, or the California region. So I think it's up to those regions to also, you know, figure out what the mix is between the various energy needs and sources of mobility. So I think a lot of those regions, from what we've seen, are in their green prints, they have hydrogen as a bigger component.
Oh, very good. Thank you for that. That's a great point. Also, I just spoke about the infrastructure bill. Obviously, the second stage, if you will, is the Build Back Better legislation that is on the table. No probability assigned to whether that's going to pass and in what form. But obviously, everybody in kind of climate change sector is looking forward to seeing some additional funding coming from that legislation. The second area, I'd say we did get some questions about what specifically came out of COP26 regarding hydrogen. I'll ask both panelists to chime in if they saw anything. What I had seen over the course of my expedient research, not so much directive coming directly and focused from COP26, but a lot of global companies used and took advantage of the time period to announce a lot of initiatives themselves. That seems to be kind of the play that took place over the last 2 weeks. Again, Stephan, Ash, did you see anything a little bit different or was that in line to what you've seen?
I think that's in line what you saw. And as Hydrogen Council, also we were invited by the Scottish government. Actually, there was big interest in side events and other events in COP in Glasgow to discuss the potential of hydrogen.
Great, great. So let's go into our questions. Like I said, we did receive about 30. There are a couple overriding themes. And while your presentations were very future and forward looking, the biggest overriding commonality among the questions probably has to do with past perception and really regarding safety of hydrogen. Of course, in the United States, when people think hydrogen, many people still think of the Hindenburg, and they still think of what happened then because hydrogen had the reputation of being a volatile fuel. So what I'd like to ask both panelists is to talk briefly about what you were seeing in terms of the safety of the technology being utilized in hydrogen, whether it's at the vehicle itself or in the infrastructure, and also maybe put it in context with, the gasoline infrastructure that takes place, and compare the safety levels of hydrogen to like the existing oil refinery / gasoline refinery safety, and are they better, are they worse, and what you can add to that.
Maybe shall I start?
Please.
I think first, hydrogen is a gas, and we need it to treat it as a gas. The advantage of hydrogen is it is lighter than air. So in case of a leakage, hydrogen immediately disappears. It goes up. If today a petrol or diesel car is catching fire, the fuel stays around the car and the car burns down. In case of an accident, we have equipped the Mirai with sensors all over. So if there is an abnormal situation, hydrogen is automatically being released. In worst case that hydrogen should capture fire, actually it is like a jet flame. So it is the fire is directed upwards. So it doesn't stay around the car. And in that sense, it is safer. We also have now more than 10,000 fuel cell cars globally on the road. And that is normal. We had normal traffic accidents in Europe. We had people who forgot a cigarette in the car and it catched fire. Nothing happened. So the tanks, the system is proven. And also we have to do with the tanks fire gun tests. Recently, BMW, they went to a military area and they have put a grenade, I don't know if this is a proper English word, a small bomb under the car, and actually nothing happens. You can visit in the BMW world in Munich, you can see the piece that was under the car, how it looks. So we do everything to make this technology as safe as possible, but it is a gas and we need to treat and we need to handle it as a gas. But again, the advantage is it is lighter as air. It doesn't stay where it is, it goes up. I don't know,
Ash, any comments on that as well?
Yeah, well said, Stephan. I think the only few points that I would add is, as Stephan mentioned, you have to treat it with respect. Any flammable substance you treat with respect. That being said, I think there are a lot of safety advantages. He mentioned the lighter than air, the no pooling. Any technology or any, again, system is going to have challenges, right? There's thousands of gasoline fires each year, whether it's the vehicle side or the station side. We have battery electric cars that have fires, right? I think hydrogen's safety record is actually better in many ways, and those advantages that mentioned, we strike them with lightning, we shoot them with 50 caliber bullets. The tanks are the toughest part of the vehicle, all the safety factors that Stephan mentioned. So they're quite protected and strong. I think it's unfortunate. I think a lot of people think of the Hindenburg or the hydrogen bomb, right? So that latter one shows the power of hydrogen. But of course, there were nuclear bombs and gasoline bombs, napalm bombs, right? It's interesting what is remnants from the past are stuck. But I think the bigger picture is those are, they're not misplaced. It's a great question. What is the safety situation? And to us, it really goes to the education. So that's such a key piece of all this is helping people understand it and get to grips with it. I think Stephan mentioned, hydrogen's been used, it was used in gas lamps, a century ago. It's used daily for the same amount of time in refineries, as you mentioned. So again, we have to treat it with respect, but we've seen, with many generations on the road now and thousands of vehicles in the wild, that it's actually has a lot of safety advantages.
That's great. Thank you both. Kind of along those lines, we did receive a couple questions where people really recall their technology history, and they recall a period in the 1970s and 80s when hydrogen was being contemplated as a fuel directly into an internal combustion engine, an ICE. And so what happened with that type of research, and why did it migrate towards using hydrogen in fuel cells and not necessarily just as a substitute in an internal combustion engine?
Maybe I can start that one as well, Stephan. Yeah, it's another great question. And the reality is that when hydrogen is used in the fuel cells, it's true zero emissions, right? You're only getting water really as the output. When it's used in an internal combustion engine, it's much better emissions than a regular internal combustion engine, but it's still being burned. So there is some of the metal inside the engine does burn and flake. So there's a small percentage. So it's not true zero emissions. That being said, I think it's a great example. Our president, Akio Toyoda, as an enthusiast, he was racing in some of these endurance races rather. Our latest Corolla Sport has hydrogen, ICE, internal combustion engine, as an example of really great performance and much better emissions than your standard gasoline car. So that is being pursued, and that is quite relevant to today. The biggest challenge, and one of the reasons it hasn't been spread again, has been the infrastructure, right? Hydrogen is widely available and used around the world, but not for mobility in the past. And so that has been the key. There hasn't been stations to fuel up, fuel cell vehicles or hydrogen internal combustion engine vehicles. So I think that last example is very relevant again today, and has its place again as we need to use all levers. But we're really most interested, I would say, in carbon reduction as fast as possible, as Stephan outlined. And so zero emissions is always our goal when achievable.
Stephan, any thoughts?
Maybe just to add that an internal combustion engine obviously is less efficient than an electric powertrain. And this results that if you burn actually hydrogen in a combustion engine, you have a consumption that can be up to 30% higher than if you utilize the hydrogen directly in fuel cells. So that is another reason why fuel cells are much more efficient than using combustion engine and hydrogen.
Great. Thank you, Stephan. I agreed. Kind of looking at the question list here that I wrote down, there's another theme. Not necessarily every question is the same, but in the fact that people want to talk about context of spending money and spending capital on developing a hydrogen infrastructure, and what is that relative to the costs of developing other infrastructures, whether it was the oil and gas infrastructure in this country, et cetera, et cetera. The one question I think is, does the hydrogen infrastructure really, at least in the United States and maybe in the EU as well, does it really need to be developed nationwide so it's accessible by everybody if hydrogen is only at this time seem to be more apparent for, say, commercial vehicles and trucks, et cetera? Like, how can you tailor the distribution of hydrogen in a way that's very as efficient as possible in terms of capital intensity and the use of capital, but can also kind of satisfy the demand on the larger scale vehicles? Don't know who wants to take that first.
Maybe I can start. I think we see different models at the moment. We have Japan or Germany, where the government decided to invest massively in a countrywide infrastructure. So now Germany has now 93 hydrogen stations, but actually they're lacking passenger cars, probably 8 or 9 cars per station. So we need to accelerate. It's now our job to accelerate to bring these vehicles to the market. But indeed, the biggest challenge is how to align. Where we have vehicles, there are stations, and where stations, there are vehicles. Therefore, we are trying now to make these partnerships. I mentioned Air Liquide and the taxi projects we have in Paris. I mentioned Copenhagen. I mentioned Uber in Germany. And now increasingly, we are adding the bus, because bus obviously is a high consumer like the truck. So with 10 buses, we can already show a business case for a hydrogen station. So in a combined world, when we can offer the bus together with Mirai, it makes more sense for the infrastructure. So we are trying to identify these ecosystems, and then gradually the ecosystems connect to build up the wider infrastructure. And this is also promoted, recognized by the European Commission. So now there are projects going on to, sometimes it's called hydrogen valleys, sometimes it's called hydrogen ecosystems. But the key is really to align the supply and the demand in certain places.
Ash?
Thanks, Eric, and well said again, Stephan. The other thing I'd add is that I think the heavy-duty trucks and the buses are a great spearhead, if you will. So introducing hydrogen, once you're introducing a station for the trucks or the buses, which I think is the easy first step, you're introducing it for mobility, and it's there's good scale economy savings from then. Just now that it's produced or dispensed in a particular area, you can run a separate set of light-duty islands. So it depends, but we've already been doing that in California, for example, as a natural kind of synergy. And again, I think the longer range, 845 mile Guinness Book World's Records, right? I think it depends on how you drive, right? That's a hypermiler, but if you're getting 400-mile range like the EPA label, then you really don't need all of the same saturation as the gas stations, right? Gas stations are oversaturated, to be honest. So we have really good high-tech modeling with the partners that Stephan mentioned to show, where are the smart points to put in hydrogen stations. And I think, again, often those coincide with, freeway interchanges where you can service both, passenger vehicles and heavy-duty trucks and more.
Great question. It's funny, while you guys were answering this question, it got me thinking a little bit, and here one of our listeners asking a very similar question. 10 years ago, we talked a lot in this country about natural gas and compressed natural gas and liquefied natural gas also being a transportation fuel. That it seems like that conversation has died out a little bit, and it feels to me that hydrogen is more the substitute, if you will, for the larger vehicles in terms of R&D being spent as a cleaner propellant. And then one of our listeners said a recent New York Times article stated that blue hydrogen isn't as environmentally friendly at all. And in fact, you'd be better off burning natural gas instead of going through the hydrogen conversion process. And I just want to know if you can give us a little bit of relative analysis about hydrogen versus natural gas, and if that debate is taking place at all right now.
Yeah, maybe I can start that one. Another great question. I think, natural gas has some good qualities and attributes. I think there are also a couple of things that hold it back and have a lot of people now recognizing it as more of a transition or a technology that's maybe, again, a transition, not an end game. Zero emissions and is the end game. So hydrogen can be zero emissions, right? But it does, just like battery electricity, it does depend on where it's produced. So the vehicle side of natural gas had lesser performance than the benchmark, which was diesel, right? So they had a lot of challenges with their compressed natural gases, and I don't think they ever got over that. Fuel cell electric, for example, has better performance than diesel, right? More electric torque, et cetera. So you don't have that issue. And again, as I mentioned, hydrogen can be zero emissions. The blue hydrogen, green hydrogen question is a great one. And I think, the New York Times article was very valuable, in my opinion, for starting the conversation and really underscoring the importance of making sure that well-to-wheel picture is understood. And the situational context, and we've talked about it, I think, for a good reason today, a fair amount, is each region has a different energy footprint or available, some may be a windy region, you may have room for solar.
You may have hydro right next to it. So it really depends each area on the energy draw. That being said, I think the article, a lot of scientific minds, including Stephan's, I think, see there's much more. I think the assumptions that were made in the article on the static nature of carbon capture and sequestration were maybe a little, again, static and rooted in time. I think since then there's been so many improvements for these. Whatever process you throw R&D money at, you're going to continue to improve and refine it and increase the yield percentage. So I think that's one big area that at least our scientist team has pointed out, that there's huge potential for the blue hydrogen to be much better than that article depicted in terms of the sequestration. That being said, I think, again, zero emissions is always our end game, whether it's the mobility side or the infrastructure side. And I think electrolyzers now, again, with this commercial level scale, really brings the cost down. And you've seen a lot of projects starting to take shape. A couple of North America example would be one Niagara Falls, I think 17 million by I think it was Linde this time. Big electrolyzer, right, for hydrogen production. Air Products has announced, 4 billion for hydrogen production. A lot of it's kind of green and ammonia carried based. But the point being that the blue and green paths, they're paths, right, which indicates a time element to all this. So we always want to go towards green, but again, you want to leverage all that you have, and I think blue can be quite valuable.
Stephan, are they having the same conversations in Europe that maybe in articles and news analysis as here in the United States, comparing gas and maybe the hydrogen manufacturing process and how clean it really is?
I think to utilize gas directly, as Osher mentioned, the target is really decarbonization and carbon neutrality. So we need to electrify transport. That is very clear. Still, discussions are going on in European Commission if we only allow green hydrogen or blue hydrogen, and if blue hydrogen, what are the conditions? So what are different levels, CO2 levels of hydrogen production that are acceptable? So that is a discussion that is currently going on.
Very good. And I think that conversation will continue as we kind of sort out how we should allocate capital efficiently for these next generation technologies.
Yeah.
One clarification, somebody was asking to clarify well to wheel, but for me, that's the kind of a way of saying extraction all the way to the usage of the fuel. Is that correct?
Yes, that's correct. Sorry, there were some abbreviations. I tried to sort them out, but there were still some in there. So indeed, well-to-wheel emissions is from the sourcing of the fuel, the refining, until you burn it in a vehicle.
Correct. And thankfully for our listeners, there's no quiz at the end of this webinar, so we're okay. Funny theme, I want to kind of get to some like maybe pointed but interested questions. We had two questions about cold weather, something that's being talked about, of course, in the Northeast right now because snowflakes are starting to come down. One is for battery electric vehicles, we've always talked about degradation in the wintertime of the battery, and therefore range is dropped off. Are there degradation issues when it comes to hydrogen fuel cell? And then somebody asked a really interesting question. Given that we're talking about water vapor as an emission, can there actually be a danger to having in cold temperatures water vapor as an emission on roads itself and causing perilous conditions? I thought that was really interesting perspective.
Yeah, maybe I can take a stab at that one. I had the same question. I was fascinated. I was like, okay, I understand for the passenger vehicles, the amount of water vapor that's generated isn't enough to freeze or cause any condition. But what about the heavy trucks, right? We're proving that not to be the case as well. And there's various ways you can route and can control, the rate of the water emissions. So good question. I had the same one back when I started in this, maybe 7 years ago or so, but not an issue. I think the cold is challenging on any kind of machinery or mobility. That being said, and again, this is one of the reasons I wanted to present the heavy duty truck example, because it's such a great use case for so many things, including life cycle performance, right? These trucks run millions of miles and have much higher operating requirements than passenger vehicles in many ways, which simply aren't used as much on a daily basis. So whether it's the cold weather or the the degradation over time or the life cycle durability, it's a great case study, if you will, for these various technologies. And the truth is, fast charging, just like with our phones, you can optimize your charging schedule, but if you continually to fast charge, particularly the larger the battery in the truck's case, then you really do get significant degradation over time if you continually fast charge a big battery. The cold weather, I think the AAA study was maybe there was a roughly, I think they did Nissan Leafs and Teslas and had about a 30% range hit in the typical cold weather that it was experiencing. And Eric, to your point, I think the cold weather spikes and the hot weather spikes because of climate change are becoming more severe. So it's not just a cold weather thing. Batteries require, particularly big batteries, a tremendous amount of cooling, even more so than the fuel cell electric. So the performance in extremely hot temperatures and extremely cold temperatures is what we're seeing more of over time is challenging for the performance and the efficiency of batteries. Last thing I'll mention there is also kind of when you're starting to read your end of charge or end of the tank, to use kind of internal combustion term, the battery performance starts to degrade, whereas fuel cell electric, you get the full performance all the way until the end of the charge. So there's several advantages in the space.
Great. Stephan, anything else to add for that? Cold weather is in Europe as much as is in parts of North America.
Absolutely. No, I think fuel cell is less impacted, as said, than battery electric vehicles by cold. And also because the stack is producing electricity and heat, so we can automatically use this to heat also the interior of the car. So that's also what we utilize, for example, for the buses. So cold is less an issue for hydrogen vehicles than for battery electric.
Oh, that's great. That's great. We're receiving a couple, and first off, it's we just crossed the 6:30 hour, so I think we'll be wrapping up rather quickly. A couple questions we've got with some commonality. Several years ago, nobody can talk about battery electric vehicles without talking also about autonomous driving. And so the question for both of you is the research that's being done on hydrogen fuel cell as a propellant, are they also being talked about in the context of these vehicles having autonomous capabilities? Is there a special need or anything that has to be evaluated for hydrogen in the correlation of autonomous, any different than the way it's being evaluated for battery electric?
The quick example I'll use is it's telling, I think the two in the Toyota lineup, the two most advanced vehicles in terms of the driver assistance and autonomous type connectivity are the Lexus LS and the Toyota Mirai, the new generation, right? So that's Toyota Mirai is the fuel cell electric version. So no, if anything, it's a benefit, any electric vehicle, because you have more electrical power to help power the ancillaries and all these systems. So they go hand in hand, and it's a natural fit.
Great, great. Well, you know what? I'm looking, and most of our other questions I think you covered. There's still a lot of questions that we're getting about understanding how the infrastructure will be most effectively delivered. So what I thought is, even though we're just over the 6:30, and I know we have a little bit of time left, maybe in your closing thoughts, can you just talk a little bit about what you think is really essential from an infrastructure standpoint? What are the next steps in order for us to be very smart? A lot of people have asked about redundancy. Are there too many organizations and companies kind of competing and doing redundant research? And as a result of that, we're not being as effective and efficient in executing on a global hydrogen strategy. So maybe in your closing statements or thoughts, just talk a little bit about what you think can be done most effectively to get hydrogen really in front of so many different players that could use it.
Maybe I start. The key challenge is to get the cost down as fast as possible. And so the infrastructure will benefit from that, same as we OEMs do. What we see today, and this is something we need to break through, that for buses or the other applications, customers first want to have a demo. But a demo means the infrastructure side needs to build a station for 1 or 2 or 3 vehicles. So this is something that doesn't work. So we need to come to a model actually where at the same time we can start to scale up the number of vehicles and than the stations, like what I mentioned, the ride-hailing schemes. Or we are developing currently a so-called one-stop shop offer in Europe. That means that with partners, we will be able to offer the infrastructure, the fuel, and the vehicles at a per kilometer price to customers. So this will also help that customers who are not so familiar with the hydrogen, maybe do not trust yet, we say, yeah, okay, I will try. I take 10, I take 20 buses, I take more vehicles. And if it doesn't work, I can return them. I pay a leasing fee. And so we want to take away the risk actually from the customer, so that enables the scale up of this ecosystem.
Thank you. Ash, any thoughts on similar to Stephan?
Yeah, thanks, Eric, and well said as usual, Stephan. I would say that again, recognizing as a public-private, societal level that kind of all solutions are needed. Again, the situational context of the region. So to me, that means, certainly in the US's case, continuing this good national support. I think this is will be huge to influence that. I think the EU has done a great job in Europe, but for the US, also besides the national level, is the region support. So understanding the New England region or the Massachusetts-Boston region, right? These are big cities and ecosystems and ports, and this is a global shared challenge of how to do this energy transition. So it's sitting together, leaders from public and private in the community, and understanding that, okay, what is our green print? And understanding that you need battery electric, you need fuel cell electric, but understanding really that the tail is wagging the dog a little bit if we just keep the conversation at the passenger vehicle mobility level. The main chunk of this is the infrastructure, which is where the government is so important, and the local community and the ports and everything, the airports, because the infrastructure needs, the big energy needs, and the utilities, the state utilities, right? The natural gas grids, all of that, they need to be at the table together. I think Stephan pointed this out earlier, to aggregate and align the conversation on, okay, where are we today? What assets can we leverage? Where do we want to be? We want to be zero carbon. Okay, so the goal's pretty good and clear. How do we get to zero carbon from where we are today? And you really want to smartly leverage what you have today, but also smartly invest in that, as I mentioned, versatile, scalable, future-proofed infrastructure. It's such an expensive investment. You want to do it right now so you can bridge to that zero emissions future. And I think the tipping point has been reached where the majority of the conversation now is understanding that hydrogen, whether it's the storage of renewables alone and helping the grid alone, is really a crucial part of this, not just the mobility side. Thanks so much.
Yeah, thank you both. Maybe one last quick question. I know I get a lot of questions from people about where to find good sources of information when you just want to kind of stay on top of things. There's some great websites. One of my favorites is called Clean Technica, that really gives everyone an overview of what's happening in clean energy and sustainability. There's very good trade publications for specific, like for electric vehicles. Charged EVs is very good. Where do you guys recommend for people to go to outside of traditional media if they want to get a little bit more information about where things are happening in hydrogen, and maybe just for vehicle and alternative fuel vehicle technology in general?
I mean, a general source is for sure the Hydrogen Council. If you go on their website, we did studies on cost, on the decarbonization pathways, on transport. Now we do on materials. So we look step by step into all aspects of hydrogen, gather the information and make this publicly available. And also we track, as I have shown, the investment in hydrogen. And because we want to know where are we have shown the way where we want to be in 2050. Now we started to track actually what are the investments, are we on track to achieve our 2030, our 2050 targets.
Great. Ash?
Yeah, I agree. I think that Hydrogen Council is a great place to start, simply because it's obviously hydrogen is an important focus by the constituents, but it also has so much credibility, in my opinion. McKinsey consultants help provide, so there's definitely an objective lens on what is needed rather than pushing agenda, I would say. That being said, I think, Bloomberg and Wall Street Journal, the general media now, electrification is really a part of all of this conversation. So I think the more people read, the more they're informed. And again, I think there's no one silver bullet or solution. So understanding everyone's viewpoints, and again, I think uniting around the common need for zero carbon and the transition, I think, is a great place to start. But I think the Hydrogen Council speaks to that education piece. Again, everyone, I think, understands batteries and battery electrics much more. So hydrogen, fuel cell electric, it's such an important role that it's criminal in a way not to understand what it can provide and bring. So I think I would also advocate for the Hydrogen Council links that Stephan mentioned.
Yes, and it looks like, I believe it's very simple, hydrogencouncil.com, and then you click on the English tab or /EN. Thank you both. You guys are fantastic. We have to give a little bit of a special shout out to Stephan because it's pushing 1 o'clock in the morning in Belgium. Maybe the pubs are still open, I'm not sure yet, but thank you for, usually after 8 or 9 o'clock at night, I can't really have an intelligent conversation with anybody. So thank you for stepping up and keeping your game. And Ash, thank you very much. It was great that we had a North American representation, European representation, and both gentlemen with a fantastic global Asian company. So with that, I will turn it over to James for some closing thoughts on behalf of OLLI.
Well, you've summarized it very well, Eric. I want to thank all of you for this excellent presentation. It's such a key topic, and you've clarified so many things. So we're very grateful to you, and we thank you very much for your participation, and Eric for your excellent moderation. And on behalf of OLLI, I would like to thank all of you who are here tonight, who have followed the discussion. Thank you for your presence and for your excellent questions. And I suggest that you look at the OLLI website because there are many more interesting topics coming up. And we look forward to seeing you all again soon. So thank you very much and good evening.
Thank you so much. Thanks, James. Thanks, everyone. Thanks, Eric.
Thanks a lot.
Good night, everyone.
Good
Get
night.
some rest, Stephan.
Yeah.
Okay, cheers. Bye, everyone.
Cheers. Bye.